Welcome back, folks. Let's get back after it. Chapter 10 here, comparing two populations or groups. This is what I'd like to call our practice test for this chapter. It's really just some exercises out of the book. We're going to be looking at 14, 16, 18, about steroids in high school, and we'll be looking at 42 and 48, DDT and rats. Those are, I think, representative problems of the two different types of inference tools here for proportions and means. So let's go. First set of problems we'll look at here is 14, 16, and 18, steroids in high school. A study by the National Athletic Trainers Association surveyed random samples of 1,679 high school freshmen and 1,366 high school seniors in Illinois. Results showed that 34 of the freshmen and 24 of the seniors had used anabolic steroids. Steroids, which are dangerous, are sometimes used in an attempt to improve athletic performance. Do the data give convincing evidence of a difference in the proportion of all Illinois high school freshmen and seniors who have used anabolic steroids? State the appropriate hypothesis for a test to answer this question and define any parameters you use. So real quick here, I want to highlight something. As I read through this, I see the following words: whoosh, evidence of a difference. That automatically tells me I'm doing a two-tailed test. When it comes to time to do a significance test. All right, so let's go ahead and start taking a look at this problem. This is question 14, this is question 16, and then down below is question 18. I'm just kind of merging them all into one question. So let's take a look here. We have freshmen. This is just a summary of the data that's given in the problem. We have freshmen with this sample size and this sample proportion, p hat sub f. Notice I used the hat symbol there because it is a sample statistic. And then the same thing over here, those sample data for the seniors. So we're going to start with our four-step process: state, plan, do, conclude. Here's the state. Perform a significance test at alpha equals 0.05 of the null hypothesis p sub f minus p sub s equals 0. Notice that I've used p without a hat here, and that's important because when we do a hypothesis test, we are trying to look back at population parameters. We are using our sample statistics for inference on the population parameters. The alternative is that pf minus ps is not equal to 0 because, again, we're looking for a difference, so that's a two-sided test, where pf is the true proportion of freshmen in Illinois who use steroids, and p sub s is the true proportion of seniors in Illinois who use steroids. Okay, so now let's take a look at the plan step. Plan. We're going to perform a 2-prop z-test if conditions are met. Let's take a look at those conditions. Random? Sure was. Data was collected from random samples. Notice I said samples here because we have to identify both that the freshmen and the seniors, the two different populations, we sampled randomly from each of those populations. 10% condition, we're going to assume that the sample size for freshmen and the sample size for seniors are both less than 10% of the respective populations. And then check the large counts condition. We did n times p hat for each, and n times 1 minus p hat for both of the samples, and all four of those values are at least 10. So all conditions are met. We can go ahead and do our inference procedure right now. I did a 2-prop z test on my calculator, and I got a z value of 0.5382, which gives me a p value of 0.59. I just want to run through the calculator steps there real quick and show you how that works. So let's jump over to the TI Inspired CAS calculator and take a look at this. We're going to go Menu, Statistics, Stat Tests, and we are, whoa, heads up, we are running a 2-prop z-test. So for the freshmen, we had 34 say yes, they had used anabolic steroids. And we had a sample size there of 1679. For seniors, we had 24 say yes, with a sample size of 1366. And again, the alternative hypothesis there was that there is a difference, two-sided test. Okay, grip it and rip it, and I get my z value, the test statistic of 0.5382, and that's a two-sided p-value of 0.590438. So now we are ready to state our conclusion. Boom. The p-value of 0.59 is certainly greater than the alpha level of 0.05, so we fail to reject the null. There is not convincing evidence of a difference in storage use for freshmen and seniors in Illinois. So I want to highlight something here in this conclusion. Remember, when you are stating a conclusion of a significance test, be very careful to not say anything remotely close to, oh, I accept the null. So what I'm saying here is there is not convincing evidence of a difference. That is not the same thing as saying there is no difference. So be very careful about that. Okay, that's done with the significance test. So let's go down and look at this next part of the problem. Construct and interpret a 95% confidence interval for the difference between the population proportions. Explain how the confidence interval is consistent with the results of the test. So let's go ahead and take a look at this on the calculator. So I'm going to go Menu, Statistics, Confidence Intervals, 2-prop-z interval. For freshmen, we had 34 say yes, with a sample size of 1679. For seniors, we had 24, with a sample size of 1366. I want to make a comment here about the 2-prop-z interval versus the 2-prop-z test. Now, if we have a 95% confidence level on our interval, we should get the same results as we did for a alpha value of 5% on a two-sided test, because those two are mirror images of each other if you're doing a two-sided test versus a confidence interval. So we grip it and rip it, and let's see what we get. We get a lower level of 0.007011, an upper level of 0.012373, and let's see how we will answer this question. Explain how the confidence interval is consistent with the results of the test. So that 2-prop-z interval gave us this result, which is also a test statistic here of the difference between the two proportions plus or minus the margin of error. The confidence interval is consistent with the significance test because the interval includes 0. Notice that 0 is on this interval. And that would indicate no difference between P sub F and P sub S. Okay, folks, that's it for this set of questions. Let's shut it down, and then we'll talk about the next two.